Are you preparing for system design interview? Then this video is a must watch for you. In a system design interview, discussing design trade-offs is crucial. This shows a good understanding and thoughtful approach to system design. In this video, let's explore one commonly discussed design trade-off, monolith versus microservice architecture. Hi there, welcome to Tech and Career Guides. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product based organization. Knowing about monolithic and microservice architectures is not just for interviews, it's useful for our work too. In my 20 years of experience, I've had the opportunity to work on both these architectures. Discussing these two architectures in this forum will take me back few years. So let's begin our discussion with the monolithic architecture. Monolithic architecture refers to a traditional design approach where an entire application is built as a single indivisible unit, typically comprising multiple interconnected components or modules. In this architecture, all functionalities such as user interface, business logic, and data access are tightly coupled within the same code base. Let's discuss the key characteristics of this architecture with some real world examples.
Key characteristics.
Single deployable unit means that the entire application, including its various components and functionalities, is packaged and deployed as a single unit. Any updates or changes to the applications require deploying the entire monolith. In its early days, Amazon relied on a monolithic architecture, deploying everything front end, back end, database, and more as one unit. However, later on, Amazon shifted much of its code base to microservices architecture. In Monolith, all parts of the application share the same database and components. This simplifies development and ensures consistency. A classic example of this is the original architecture of eBay. eBay initially used a monolithic architecture where all product listings, user data, transaction records, and other information were stored in a single database. Though this setup allowed for simplicity in development and ensured consistency across the platform, it also led to scalability challenges as the platform grew. In monolithic architecture, the development, deployment, and scaling processes are all done for the entire application as a whole. There is no option to develop, deploy, or scale only a part of the application. A real world example can be found in early versions of Twitter. Twitter initially started as a monolithic application where all tweets, user profiles, timelines, and other features were managed within a single code base. Development teams worked on different parts of the application, and deploying updates or scaling the platform required coordination across the entire system. Few years back, I was working for UK's number one online grocery retailer. I was leading the auto management system for their non grocery platform. The entire non grocery platform initially was one large monolith, which became difficult to scale. Deploying any updates took almost a week, and whenever we needed any changes, it meant getting all 15 teams together to work, which was very painful and time taking. That is when the company decided to switch to microservices architecture, and I got an opportunity to experience that transition. Monolithic architecture, despite its limitations, offers several advantages that makes it suitable for certain applications. We will explore its limitations later in this video. Let's first understand the advantages monolithic architecture offers.
Advantages.
Monolithic architecture is straightforward in design, development, test, and deploy, with all components contained within a single code base. Developers can work on different parts of the application without worrying about inter-service communication or dependencies. This simplifies understanding development, test, deployment, and maintenance. For example, platforms like WordPress and Drupal initially adopted monolithic architecture, enabling quick website customization using a single code base. Scaling a monolithic application involves replicating the entire application stack, ensuring uniform performance across the application. With monoliths, there is no provision to scale only part of the application. Monolithic applications can achieve high throughput and low latency as there is no inter-service communication overhead. With all components tightly integrated, monolithic applications perform well, especially for predictable workloads. For instance, content management systems like Drupal initially adopted monolithic architecture for its simplicity and performance benefits. Monolithic architecture ensures consistent data handling and transactions within a single application, simplifying data management and reducing the risk of inconsistencies. For example, traditional enterprise applications like SAP ERP systems rely on monolithic architecture for centralized data management and transaction processing. There seem to be a lot of advantages using monolithic architecture, right? But then, why many tech companies shifted attention towards microservice architecture? Here are some disadvantages of monolithic architecture. This will give us clear understanding of why microservices are highly discussed.
Disadvantages.
Monolithic applications can be challenging to scale, particularly when specific components or features require more resources. This limitation can lead to performance issues during peak usage times. For example, if Amazon were to stick with monolithic architecture during holiday sales events for its scale, Amazon might have struggled to handle increased traffic, resulting in slow response times and potential downtime. Managing large monolithic applications is tough as they grow, leading to challenges in consistency, stability, and efficiency. Changes in one part can disrupt others, making tasks like bug fixing and updates time consuming and prone to errors. Deploying the entire application together increases the risk of downtime, especially critical in sectors like banking or insurance, where legacy systems often become cumbersome to update and risk operational disruptions. Monolithic architectures often employ a uniform technology stack throughout the application, which can hinder the adoption of new technologies and limit flexibility in using different languages or tools for various components. This technological uniformity in monoliths may impact innovation and make it challenging to adapt to evolving user needs and industry standards. Monolithic applications lack modularity, making it challenging to update or replace individual components independently. For example, an e-commerce platform like Shopify may struggle to introduce new payment methods without affecting other parts of the application. These downsides show that monolithic architecture has limitations in flexibility, scalability, and maintenance. That is why many organizations are switching to modular and distributed architectures like microservices for better agility and scalability. We will explore more about microservices architecture in few minutes. So stay tuned. Monolithic architecture is recommended in scenarios, particularly when simplicity, unified technology stack, ease of development, and rapid deployment are prioritized. If the application's scalability requirements are modest and there are no immediate plans for significant growth, then monolithic architecture can be sufficient. Now, let's discuss microservice architecture. In microservices architecture, An application is comprised of several loosely coupled and independently deployable services. Each service is responsible for a specific business function. These services communicate through well defined APIs and can be developed, deployed, and scaled independently. This allows for greater agility, flexibility, and resilience in complex software systems. Microservices architecture offers several advantages. Let's discuss them and understand why they have become the favorite of many tech companies.
Advantages.
Microservices enable independent scaling of services based on demand, improving resource utilization. For instance, Amazon utilizes microservices to scale different components of its e-commerce platform independently. During peak shopping seasons such as Black Friday, Amazon can scale its checkout, recommendation, and inventory services individually to handle increased traffic efficiently. Microservices architecture encourages technology diversity by allowing teams to choose the most appropriate technologies for each service. For example, Netflix leverages microservices to power its streaming platform. Different teams can use the technologies best suited to their services requirements, leading to faster development cycles and continuous innovation. Microservices promote fault isolation, where failures in one service do not impact the entire system. This resilience ensures uninterrupted service availability even in the face of failures or disruptions in individual components. For instance, PayPal employs microservices to process online payments. If there is a failure in the payment processing service, it does not affect other services like user authentication or account management, ensuring seamless transactions for users. Microservices architecture makes it easier to manage, update, and deploy individual services, enhancing agility and reducing the impact of changes. Each service can be developed, tested, and deployed independently, streamlining the maintenance process and facilitating faster interaction and innovation. Microservices architecture enhances developer productivity by enabling smaller autonomous teams to develop, deploy, support, and iterate on services independently. This autonomy leads to faster development cycles, improved collaboration, and increased innovation among development teams. Microservices architecture enables continuous deployment and delivery practices, allowing teams to release updates to services independently and frequently. This supports agile development process and ensures rapid delivery of new features and improvements to users. For instance, Google employs microservices to power its suite of productivity tools like Google Drive and Gmail. Updates and enhancements can be rolled out seamlessly to users without disrupting service availability. While microservices architecture offers various benefits, it also comes with certain disadvantages. Here are some.
Disadvantages.
Microservices introduce complexity in managing interactions between services. Developers must design and maintain communication protocols, handle network latency, and ensure data consistency. Each service needs its own infrastructure, deployment pipeline, monitoring, and scaling mechanisms, incurring cost. These complexities adds overhead to development and operations. It also requires specialized skills. Microservices rely on network communication, introducing challenges like latency, potential failure points, and security vulnerabilities. Ensuring performance, reliability, and fault tolerance requires extra effort in error handling, monitoring, and recovery. Microservices often distribute data across the services, leading to challenges in ensuring consistency, integrity, and synchronization. This complexity is heightened in scenarios involving transactions and data updates across services. Debugging and testing microservices based applications can be more challenging than monolithic ones. Identifying issues across distributed services requires specialized tools. Testing interactions between services and ensuring end-to-end functionality adds complexity. Microservices architecture requires a sophisticated deployment strategy, often involving containerization and orchestration tools like Kubernetes. Managing version compatibility, updates, and configurations across a distributed environments can be complex. These disadvantages highlight the challenges in building and operating distributed systems using microservices architecture. Organizations should carefully evaluate their requirements, technical capabilities, and operational readiness before adopting microservices architecture. You might have heard of Amazon's decision to revert the architecture of its video monitoring tool back to a monolithic architecture. This explains that microservices architecture is not always the best fit for every scenario. So, when is microservices architecture recommended? Let's discuss that. Microservices architecture is recommended when we need scalability, flexibility, and agility in our application development. It is suitable for complex systems requiring diverse technologies, large teams, and resilience to faults, enabling independent development, deployment, and scaling of individual services. When choosing between the monolithic and microservices architecture, it is essential to align the chosen approach with the project's requirements. Building Microservices by Sam Newman is an excellent book if you want to learn more. The link to purchase can be found in the description box. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Also, do check out our other videos on software performance optimization case studies, system design, coding, big data, and career growth. My name is Rupa, and I thank you so much for watching this video. See you next time.